Hey everybody. The class officially started yesterday, and I already have a good number of videos up for the course, as far as the assignments go anyway. Um, and got a couple more to go, but I figured since the course started yesterday, this would be a good time to I guess just make a quick video explaining a couple of simple things. As I said before in previous videos, this is an advanced course. This is a 300 level course, and it would be normally a cybersecurity elective. But two things. First of all, because the department is currently a little short on elective offerings because we're short-staffed, a lot of non-cybersecurity students are taking this course as a 300 level elective. And second, because our cybersecurity curriculum is brand spanking new, and if you are a cybersecurity track student, that means you are going to be one of the first cohort to take these courses. That means that with a combination of those two things, I can't necessarily trust that you know certain things that you would normally be learning in a cybersecurity curriculum. Because this is a computer information systems degree, not a computer science degree. That means that you learn the same things from a different perspective. So computer science has different flavors, just like humanities is basically studying the same thing from different perspectives. Computer science has different perspectives and emphasis as well. So for example, philosophy, right? What's that? That's the study of human ethos, human reasoning, human condition. Psychology, what is that? That's the study of human mind, behavior, thought. What is sociology? The study of human thought and behavior in group settings. What's political science? The study of human behavior in a political setting, so on and so forth. So essentially all the humanities is the study of humans and human behavior. Computer science is the study and application of technology, but from different perspectives. Computer science would have a lot of courses that are a lot more lower level and teaching the nuts and bolts of how technology develops and how it's used. So you would be learning in early courses, you'd be learning to read assembly code, you'd be learning what pointer addresses are, you'd be learning what CPU registers are, and that kind of a thing. Well, in addition to other stuff, of course. Whereas in computer information systems, because it is an emphasis on a higher level of technology implementation, you wouldn't necessarily need any of that low-level information. Instead, you would be learning about implementations and data structures and programming and that kind of a thing. And all of that, I'm sure, sounds a lot more familiar to all of you if you're taking a 300-level elective at this point. So that means that in the cybersecurity curriculum, we do teach assembly code, and we do teach, protocols and all of that kind of stuff. But because I can't count on you having that information, I thought maybe a short video, which I say short, but I've already been talking for like 5 minutes. A short video just kind of explaining some of the basics of what I have been doing in the course to help explain what's going on. And I have the benefit of doing this after I've completed a number of assignments, so now I know, because I didn't do this, I have not done this before. Like, I've never played this game before I started recording these videos. I've never done the CTF or any of the challenges before. So I went into this thinking, oh boy, there's going to be a lot of things I might have to do, but I'm not sure. And at this point, I've done like 4 of the things, and it turns out it's been really easy. I haven't needed to do... I mean, I could be doing much more to make this like a cooler experience. Like I could be building a trainer, and we could be doing some DLL injection, which we might have to do later on. But so far, I've been able to get through just about everything, doing static and dynamic analysis with Ghidra and Cheat Engine. So here's a quick rundown, I guess, of some of the information you're going to need for that if you don't already, just so you kind of know what you're looking at. So first of all, what we're going to do, I guess, for this demonstration is we are going to give ourselves infinite mana. Now, if we do static analysis, if we open this up in Ghidra, this is an unstripped binary, which means that essentially a lot of the information that the programmers need, there's a PDB included with the game, right? So that's our debug information. And the unstripped binary with the PDB means that we have a lot of the function names and variable names and stuff. Not all of them necessarily, but we have a lot of them, which gives us a big leg up. So if this were a stripped binary and we wanted to figure out how mana is being calculated, and so if I use mana here, you'll see my mana goes down. If I stop using mana, it starts ticking back up, it regenerates, right? That has to be somewhere programmed, right? This isn't just magic, it doesn't just happen. So somewhere there's code that says this person has 100 mana max. If that 100 is, if the current value of mana is less than 100, then regenerate by this much over this much time. And, you know, all this other stuff, the logic that's required in order to make this actually happen. So that's in there somewhere. And if it were a strict binary, we would have to reverse engineer it and put a lot of work into figuring out, well, relatively a lot of work into figuring out what code does this and all that. But because it's an unstripped binary, we can just look and see, you know, here's the get mana function, and here's the regen mana function, and so on. I don't know if those are actually in there, but yeah, just an example. So we're going to give ourselves infinite mana because that will be a good way of going through some of these features that I've just been talking about and some of the principles that you may need and may be helpful. By the way, I'm going to be putting this really early in the course. So you'll notice possibly I'm looking at OBS right now, and it says I'm at 13 frames per second. So this might not even be very easy for you to see. Let me quick. I'm gonna have to hop back and forth here. Hold on. Let me pause the video. I'm gonna kill some stuff I got running in the background. Maybe we can help that FPS a little bit here. All right. Hopefully that's a tidbit bit better. Okay. So. Infinite mana. All right, so yeah, somewhere in here is code that says, you know, this is what mana you have, this is your mana regen, this is how much the spells cost in terms of their mana consumption and that kind of thing. In the background, what you see here behind the game is cheat engines, cheat engine 7.2, as you can see. Now, I'm going to hide the game window for just a second. Actually, I don't want to hide. I'm going to make it a little bit smaller, though, so that you can see what I'm doing without being, and then I'm gonna, let's hide. Wait, why is this even there? Oh, I know why, because that. Okay. All right, I'm going to put this down here because all of this will not be information that will be needed. Okay, so we have a value here, 100 for our current mana. We also have 100 in our health, right? So we can easily influence our mana by using it, and it immediately begins to regenerate. We can't directly influence our health pool unless we take damage. And regenerating health happens, but it takes, like, there's a longer regen. Oh, there's a little something. Is that a spider? There's a spider walking on the water here with me. Oh, but I zoned in, and the other objects, yeah. Well, anyway, I don't need to get distracted and explain what that is. So let's stick with the mana thing. All right. So this is when you first open Cheat Engine. This is going to be more or less what you're going to see. So we know what our first value is, and this is going to be 100, okay, because that's our current mana. We know that this is the exact value, so we're going to keep this scan type. And we don't necessarily know the value type, but 4 bytes is, you know, or a float is possible. Because we're seeing a whole number here and it's 100, it's probably not a float. It's definitely not a string, right? Because there's some kind of arithmetic that's happening here in the background. And so it's most likely going to be 4 byte. And if it's not, that's okay, because it will actually do a search for different value types and return those anyway. So if we do a first scan here, we're going to come up with a lot of results. Okay, this is going to be every variable. And by variable, what I mean is, if you look here at our returns in Cheat Engine, we have several columns here for address, value, and previous. So the previous column is going to retain the value of the last scan unless you check this box to compare it to the first scan. If you check this box, then it will always compare the current value with 100. You'll see why that can be useful in just a moment. The value column is the current value of that variable, and it will change dynamically. And we're not seeing any changes now because none of these are changing. But if we scroll around here, we can find, okay, here's some red numbers, right? Red means that these are the current values and they have changed from their previous value in the last scan. Now, what's this all the way over here in the address column? Those are memory addresses, right? So if you don't have any previous knowledge or exposure to how memory is allocated and how all of this works, well, I'm going to come over here and I'm going to chill with the sheep. Why can't I jump over this? There we go. Cheapy! Yay! Keep me company here while I'm talking about this. All right. So these are memory addresses, and if you don't know how memory is allocated, think of it like, well, the word address is really the best kind of nomer for it, I guess. So just like if you imagine a city, every city is going to have buildings, and every building is going to have an address for the postal system. So each of those is essentially a little area, a little compartment, a little bucket, a little box, however you want to conceptualize it, where information can be stored. But just like every container, it has a finite amount of space, right? If I have a 10-pound or 5-pound bag, I can't fill it up with 10 pounds of whatever, right? It will spill over. It doesn't fit. Now that is actually something that will come into play probably later, or something that you'll learn in additional cybersecurity courses if you take them. But because it holds a finite amount of space, let's say that I have a 4-byte value, right? Like this 100. So if that doesn't fit into a single memory address, and it doesn't, it will need to spread across multiple addresses. So we will have, let's see if I can, hold on, let me get like Excel or something up. Maybe we can explain this a little bit easier. Right, rather than do Excel, I figured that there was probably a diagram out there that would do what we wanted it to do, and I think that this will do just fine. Okay. So, oh, hold on a sec. Got the old interrupt us here with the messages. Okay, anyway. All right, so looking at this chart, all right, so you can see the band on top, those numbers are memory addresses that go from 1000 to 1005. Now, we have several colored words here, I guess, that have different significance, all right? So let's say that we have a program, and that program is going to be super simple, okay? The only thing that it does is it will declare a couple of variables and then assign them, all right? Now, let's say that we have an int, and that int is called var, as you see there in green on the bottom right. And the value of var is 1, 2, 3. Now, we also have okay, first of all, we have a variable, all right, and the value is 1, 2, 3. All right, now let's say that we want to reference that variable later, but you know, if memory is allocated dynamically, we don't necessarily know what the address to that is. Okay. Now, what we need to do in that case is we can actually declare a pointer variable, and that's what you see there with the asterisk PTR. At this point, I'm guessing that a lot of you have had some significant amount of exposure to programming. Probably, I don't know if we actually teach C here, but you certainly are at least familiar with the principles of programming, so you may be familiar with that. At any rate, so we declare a pointer variable, but we want that to point to the value of var so that we can reference that in memory later on. So we declare int star pointer, PTR. Now, we can assign that value to wherever var happens to be stored, no matter where it happens to be, by simply assigning the value of that PTR, that pointer variable, to and var. So what we're looking at in this chart is all of these represent different ways of calling the same information, right? So in memory address 1001, we are storing essentially the pointer variable, Okay, and the pointer variable, that value is going to be whatever the memory address is of the var variable. So that's 1004. And 1004, that memory address will contain the value of var, or whatever it happens to be. Now, if var were to span multiple addresses, let's say that var goes from 1004 to 1006, well then 1004 isn't going to be the end of var, but it will instead continue that pointer down to the next location. So it will say, let's say it's 1004 through 1006, and each of those memory addresses will hold one digit of the var variable. So 1004 contains 1, but then it also contains a go to 105. 105 will contain the number 2, but it will also contain a go to 106. 106 will contain 3, and then it will contain an end, right? So not an end of file, not an EOF in this case, but it will be essentially a terminus for that variable. There'll be no further pointers. But that's all well and good, but memory, when it's allocated dynamically, isn't necessarily allocated contiguously. So 1004 through 1006, that's really great if they're all together, and a lot of times, you know, they will be. But if, let's say, we have other variables that are being declared, or other spaces in memory that are being reserved by something else, and var needs to span 3 addresses, let's say it's 104, 105, and then 256,000 or something. It doesn't really matter. 105, 106, and 9,999. There we go. How about that? So it will work the same way. It's just that the pointer path will continue from 105, and it'll say number 2, and then go to 999,099, or 9,999, whatever. And then it will be 3, and then it will be the end of the variable. So what we're looking at here, excuse me, I'm sorry, I'm early in the morning, and my voice is getting froggy. All right, so let's go back to the game and to Cheat Engine. And what we're seeing here in the address column is what we were seeing there in that chart. These are just memory addresses. Now you see that they're not all as nice and neat as going 1000, 1001, 1002, but that's what these all are. These are all just locations in memory, specific addresses. No two will be alike, and no two will contain, or no one can contain more information than it can hold, right? Now, one or more of these variables will contain this mana value, and we already scanned for 100. Now, it's super easy for us to manipulate the value of the mana variable by just using some up. So I don't want to hit a cow here. Let me shoot this tree. So if we use up some mana, we have now made that value less than 100. So we can come back down here to Cheat Engine and do a next scan. But we'll do for a decreased value. Whatever the value is, it will be less than 100. So let's do next scan. Now we're down to 249. Now, as you can see, the previous column contains whatever the value happened to be for that scan, right? So now our mana is regenerating, so the value will have increased from the time we did our last scan. So we'll now search for an increased value. And we are down to 10, and we can even see that there are a couple of these addresses that seem to contain the exact same value as our current mana. So we're at 88 up here, 93, 94, 95. You can see it's in sync with all of that. Now we can weed out even more addresses. There's only 10, and we can kind of see which ones they are, but we can weed out even more addresses by doing an exact value match just as we did at the beginning, but comparing it to the first scan. Not that it really matters, but... And we're down to 3 memory addresses. All of these, if we use up mana, could be in sync with our current mana value. That means that there's a very good chance that these contain the variable for our current mana. And you'll see that the addresses are nowhere near contiguous, right? The memory address 0905 CEB8, I'm sorry, my monitor that I'm reading it off of that you're seeing on is very small for me. 20005E7C and 2E87F984. Now with Cheat Engine, it's really easy to just change the value of these, right? So if we change the value of the selected address, let's change it to 999, and we'll see what happens in the game. well, actually, now that I think of it, there's probably a check. So if I try and change this value to 999, nothing happens there. You can see it actually gets set back to 1. Actually, you can see it is twitching. It's going from 999 back to 100. Now, what does this tell me? Well, this tells me that this address is most definitely related to our current mana pool. And we can change that value. But because it's being set back to 100, there's obviously some function in the game that is continually checking the mana value for our player character and setting it to 100. This is probably part of the regen function, right? There's probably a check very simply that says, if mana does not equal 100, then add whatever, or set to 100 if greater than 100, or it could be any number of things. There's some kind of logic going on, but it tells me that they are related. Now, what we could do is, if we hit this check button for active, it should reset that value to whatever we put it to, no matter, even if it changes in the game, which is really good for doing like infinite ammo or something like that. But obviously that's not going to work for mana because it's going to reset it back to 100. Right? If we right click here and find out what is accessing this address. So what is writing that 100 to that address? We'll attach a debugger to the process because that's going to be necessary. It's going to take a second because I actually have an assembly scan running at the same time. Working on magma rocks, so I'm trying to do the one-hit kill thing. Takes any longer, I'm just going to pause it. All right, I'm going to pause this until the debugger attaches. I got an assembly search running, so it's taking a little while. Okay. Well, sadly, the game crashed, so I had to reopen it and then re-scan for our addresses here. So you'll notice that they're different from the last scan, but there's still 3 and the principles are the same. All right, so find out what accesses this address. Yes, debugger, and there we go. So we can see, first of all, here in the count column is the number of times this instruction has been called. We can see that it is going up at a really steady rate. That means that this instruction is being called like, I don't know, I can't see here, like 50 times a second or something like that. And down here, if we look at the instructions, we can see disassembled what this is, game logic player get mana. So it makes sense that this would be called often because we know that there is a function in the game that's constantly checking our current mana pool and then calling something else if it needs to be regenerated or whatever. So this makes perfect sense. If we look, we can see what it's doing, right? So we've got here's our instruction right here. You can see the arrows that are pointing to it. Oh, and you also notice that when I used mana, all of a sudden this appeared. This is my callable object. And, allocator function class void. I'm not sure entirely what all of that does, but because it happens as the mana is being used and picks exactly with the regeneration of our mana, that must be the function that is associated with updating that value. So this gives us some information, right? And because it's non-strict binary, we can see exactly what function this is. There's no question that this is associated with our mana. We can see that it stopped when our mana stopped updating as well. So yeah, this function down here, whatever this is, game logic, callable object, lambda, not sure exactly. So what is this? Let's go to actually get mana. This will be a little bit easier, I think, to follow. All right, so here with the arrows is the function that is specifically accessing this memory address, the 41D57804. If we take a look here, we can see that this instruction is a move instruction. And if you're not sure, in the course of this class, if you don't understand what an instruction does, go ahead and look it up. They're not difficult to understand, and I just don't have time to go through all of them and teach everybody assembly. But essentially what we're looking at here is a move command, and that moves values in registers. So here we have EAX, and that is, what is this? I think this is Intel. Yeah, I think so. So this is moving to EAX, or moving from EAX rather, to ECX plus this string here, all right? EAX is 64 in hex. ECX is this address, which isn't exactly one. So the address where our mana is being stored is 804. This is 1D57748. But hold on, let me get a hex calculator over here. I'll show you. All right, hex calculator got. All right, so if I take cheat engine, if I take this value and I add 2, 3, 4, 5, 6, the value that's being added in our instruction. If I do this, if I add the value of ECX plus this, what do you think I get? That's right, I get the value where our, or sorry, the address where our mana is being stored. So very simply, that's what this instruction is doing. It's essentially, oh, and you know what? I bet with this hex calculator I can also show you, if we do 2, 3, 4, 5, 6, 64, the value of EAX, 100. So we can kind of infer the logic of what's going on here, right? This instruction is telling us to add 100 to the value of our mana pool. It wants to get to 100. It's obviously not doing it immediately. It's doing it in increments of 3, but it's there. What's also cool about this is if ECX is being called and not the address of our memory exactly, well, what could ECX be? Well, the answer is that must have something to do with player variables, right? That's where the player's mana is being stored. So if I get rid of this, and let's explore this address instead, browse the memory region, bring this over here, and I'm going to need to, I got to adjust my view here because we can't see. All right, pull up the game. Oh, did the game? Oh, there it is. Okay. So if I use up mana, you can see right there at the very beginning of the line, the address that we just went to, you can see the value is changing when we use mana and when it's regenerating, because that is the exact address that is, and you can see it's represented in hex, the current value. But that means that if all of this is associated with the player, if, and it's not necessarily a given, but if all of the player information is relatively close to each other in memory, we can see that there are other values that are associated with our player too, like the name, probably the health. Our current position is not. I remember from doing previous digging around here when doing teleportation, that location is stored somewhere else. But other player information is bound to be here as well. Like, I currently have number 3 selected. If I change my weapon to 4, well, look at that. We see values updating in real time there as I switch my weapons. As a matter of fact, you can see the value, the current value that's being updated there. If I go to weapon 1, it's 0. If I go to 2, it's 1. So we have an array. It's just simply an array. That value right there is the current item that's being selected. That's it. And there's bound to be other useful information there. So, what else did I want to say? Oh, right, yeah, infinite mana, right. Actually, hold on, let me See, this is the value right here that was being updated. You see it's on how it's 07. Well, this is how we can influence what we have in our, or how we can manipulate the game outside of the game. If I just change this value from 7 to, let's say, 2, so that I select my electricity spell again. Look at that. In the game, it updated to my electricity spell. That means looks like we also have another value that updates now that I'm looking at it. When we attack, it goes from 0 to 1. That must be like some kind of state where it's like is attacking kind of a thing. Or it might be an is using mana thing, now that I think of it. Let's see if we fire a bullet if it does the same thing. Yeah, it does. So it must be like an is attacking kind of state. So what happens if we go to this value that we see here? Oh, hold on, things are sluggish now, and heat engine might be crashing. Come on. I don't even know if the video is running anymore. The timer has stopped. What the hell? I don't know if you all can hear me right now. If so, I apologize. I can't pause the video. And I can play the game. That's still, I'm walking around in there, but it doesn't look like OBS is updating. Come on. Piece of shit. Disk. Why is IO pinned? Oh, because of course. Anti-malware. Of course there's a scan running. This is exactly what we should be doing. You know, as the information security officer, you'd think that I would be responsible for managing when antivirus scans run. But you'd be wrong. I don't get to make those decisions anymore. System. Anyway, where was I now? Rights. Yes. So if I use up mana, we can see that this value is the one that's updating. If I change this to 64, as the function does, so well that goes. Oh, that's right. This is a literal value. It would be in hexadecimal 64. What? Why? What? $64. Oh, my value. 64. This isn't a 1-byte value. No, it's a 2-byte value. What is going on with this? Okay. Well, at any event, what I wanted to show is that when I use the mana, it goes back to normal and changes anyway. So we're actually looking at a display value, and then there is some other value in there that's holding on to the current value. So even if we change the display value to 100 and continually reset that, the value is being calculated elsewhere as well. Let me close this quick, and now let's see if we have anything if we go find out what writes to this address. And we don't have anything just yet. But if we use some mana, we can see that the other function that appeared in our accessed, that appears here, right? So that function, the get mana function, merely reads and displays the current amount of mana. This is the one that's responsible for regenerating. And let's see what's happening here. So in this instruction, well, how much time? I'm at half an hour. Okay, I'm going to try and get through the rest of this pretty quick then. All right, so here we have another move, and it's moving 2 EDX plus this to EAX. EAX is, in this case, 62 in hex. EDX is that value right there, which ought to look real familiar to us because that's pretty much where we just were, right? Let's that. And plus 12C, so let's go to our hex calculator. And it was 1, 2, 3, 4, 5, 12C. So this is the address that's being written to. Does that look familiar? It should, because it's the address where our mana is being stored, right? So this function is responsible for adding and updating that memory address. Which means, what if we could change that, right? What if we could do something to this function to either change the value that's being updated or otherwise, let's say we could change the value set instead of updating 1 at a time, it updates 10 at a time when our mana regenerates, or instead of, whatever. Well, we can't. And there's a couple of ways that we can do that. And I'm going to do it the really simple and easy way right now, because manipulating the actual values and stuff is slightly more complicated, because especially compared to the easy way, which is simply we could update the values, we could manipulate it, we could change it, we could make it do something else, or we could just break it, right? Let's just break it. If the location in memory, if the function that reads the location can't read the location, then no mana is used or updated. So if we take our get mana function here, this instruction, and we just break it, replace the code with code that does nothing. That's called NOP, right? No operation. Well, now our mana has updated to an absurd number, and it never will run out. We can sit here and we can zap this damn tree as much as we want. The code that reads and updates the mana for our player character is broken. It will never reduce the amount of mana we have. It's changed the amount of mana that's being displayed because the code that reads that we have 100 mana is now broken. It's done for. Now, it may be fancier, and yeah, it definitely fancier, and definitely a good learning experience to go through and disassemble that code and change, because you can actually, if we go to show disassembler here, now it says NOP, but we can actually change that opcode to whatever we want. We could put in a move instruction, we could put in anything, really. That would be fancier, that would certainly be cooler, and definitely a good learning experience to go in and do that. But, this is, I'm not looking for the most clever and best solution. I'm looking for a solution. As long as you hack your way to the flag, it doesn't really matter to me how you do it. And if you have a quest that requires you to have infinite mana, this is a valid way of doing it. This works just fine, right? Now, I had thought, what I'm currently working on right now is Magma. So I had thought, maybe if with infinite mana I could burn him down fast enough that his healing wouldn't work, but I really don't think that's the case. It seems like that's not going to happen. But a one-hit kill with the ice spell, maybe that's something that we can do. I'm working on that right now. And if not, well, I guess I'll explain what I'm going to do in that video series. So what was I going to say? Oh, yeah. One last thing. So, with regards to these other values that are associated with mana usage, you'll notice that those are now absurdly different values. Oh, hey spider. Zap, 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 zap. Right, so what are these other addresses then, right? If we go to find out what accesses this address, we see that there's no get mana code. Instead, what we have is memmove, right? That's what we see there. And here's another memmove. Because these are addresses that store that value, that store part of the current value of mana, but they're not, they're part of the pointer path, right? And in Cheat Engine, you can actually do pointer scans. So if you find an address, you can do a scan to follow those breadcrumbs to get all of the addresses that work with that. Where is it? So where is it? It's table. Okay, I know it's in here. Where is it though? Okay, I know it's in here. Where the hell is it? Or am I thinking of a different tool? Am I thinking of like some other thing entirely? Oh, generate pointer map. Pointer scan for this address. Okay. Was I just not... Oh, apparently you gotta add them to the thing. Alright, well that explains that, I guess. Now where did it go? Yeah, there it goes. Pointer scan for this address. So yeah, it can do this pointer scan to work back, follow those breadcrumbs. Cheat Engine actually has a lot of features that I'm not going to cover in this course because this isn't, Cheat Engine. This isn't a basics course. I mean, we're going to use it, and I'll show you what I do to make it work. But it can also do things like DLL injection. You can see it can generate generate trainer scripts based upon what you have. Because one of the things that you're going to notice if you're using Cheat Engine and you're not using all of its capabilities is that it can be kind of annoying in that, of course, memory is allocated dynamically, and with ASLR, it may not always be in the same address space to begin with. Like, okay, so basically, when you run the program, and if you're on Windows, or well, actually, it's not just a Windows thing. So if you have ASLR, address space layout randomization enabled, it's gonna choose different memory spaces each time the program is launched to save those variables, and that's a security measure that's meant to protect. To prevent people from being able to anticipate the addresses of certain critical locations in memory to manipulate the program. But because so if you're not taking advantage of all of Cheat Engine's features, it can be annoying because every time an object is instantiated, it will have new addresses, right? So if my character in this game dies, then the current location for my position, or the current addresses related to my position and my mana and my health, will be allocated somewhere else because a new object has been instantiated. The old object is dead. But if you are using Cheat Engines to its full capabilities, or if you're doing this enough, you will note that even though the address changes, the last few digits or a few characters in hex will remain the same. That's because there's a, what do they call that? Sorry, is it alignment? Something like that. Alignment. It's not sync. But at any rate, yes. So when it allocates memory, it's different addresses, but it does try to keep things in the same sort of buckets, and that makes it easier for the program to be able to keep track of all of these things. So, for example, in this pointer paths that we see here, while my mana, the first address in mana, may not necessarily be at 41D57804, chances are it will be at XXXXX804, right? So the last few will remain the same. Just as the others that are related to mana will still probably end in D84 and 338, respectively. What I'm getting at is that Cheat Engine has the feature to generate a trainer, and what a trainer does is it will do pointer scans in order to find those memory addresses when the application launches without having to manually go searching for them. So that's a nice feature. I haven't taken advantage of it in this course because honestly, I just haven't needed to, and I'm not. I'm not going to do. I would, yeah, sure. Normally, maybe as a project, I would take it on and do something like crazy and put a lot of work into it. But I am in a position where I need to finish the videos for the assignment, and I need to get through this. And you are in a position where you are a student in this class, and so you need to finish the assignments. So if you have time to package this all up in a nice little game trainer, you be my guest. That's up to you. But if you're just looking to complete the assignments, it's absolutely not necessary to know how to do that in order to do so, and so I'm not bothering with it. Okay, I think that's about all I wanted to talk about. If you want to learn more about how to use Cheat Engine, there are a lot of resources out there. I've linked some of them up to Canvas. You go ahead and go nuts and have fun with that, crazy kids. And there's a lot of other resources out there, a lot of videos and stuff. There's some stuff out there specifically about Pwn Adventure 3, but there are also really good resources on game hacking in general, because if you can do one,
chances are you can do more. Guided Hacking, for example, has excellent forums, and they had or have, I know they had a YouTube channel. They may still have a YouTube channel, but I think it might have been banned back when YouTube updated their terms of service to ban videos that feature like how to hack videos, kinds of things. There are still some other good tutorials and channels up on YouTube. Live Overflow has a great series on Pwn Adventure 3, and I've seen bits and pieces of it, but I didn't want to watch the series because I didn't want to spoil it for myself. But I've heard some really good things, and Live Overflow's videos on other topics have always been excellent. So I'm going to assume that the videos in that Pwn Adventure series are also excellent. And that is still on YouTube because he is very good about staying within the boundaries of YouTube's terms of service. So it's definitely more from a research and learning perspective than it is a guide perspective, which is also really great for you as students because that will go a lot farther than just somebody holding your hand and walking you through it step by step. Right? This isn't a how to follow instructions course. This is game hacking. So, all right, that's it. I'm at 45 minutes. It's definitely the amount of time that I can stand to hear my own voice. So I'm done for now, and have fun out there. Go ahead and get your hands dirty. If you have any questions, don't feel like you shouldn't ask. Definitely do. And I'm going to try and wrap these videos up like by the end of next week. So then the whole course, all the content will be out there, and go nuts. And I'll just be in the game world, just kind of hanging out, I guess, right? If you see me in there, I guess. I'm going to be zooming around the island. I don't know. I know that I've had at least one student successfully complete the first assignment at the end of the first day. So that's great. Good to see. I didn't see anybody in the game, but All right, anyway, I'm going to jabbering, so we'll see you next time.